Hi, Trig class. This is second video. This is 10.1, the backside of 10.1. So we only have really two problems left to do, but this is still on the law of cosines. So we'll get going through this, get these two examples done, and then I'll kind of tell you what I want you to do for homework here. But I have to apologize. I'm trying to get these videos uploaded as fast as I can. But it takes me like 4 hours to upload one video. I don't know why it goes so slow at my house. At school, it goes really fast, but at my house, it's taken a while. So there's that. I went ahead and on the top of this page, I wrote out those two formulas from the front side just so we don't have to keep flipping back and forth. So if you want to do the same for that, that's great. So both of those are the same equation again, but just written in a different form. So this is when you're solving for an angle, and this is kind of when you're solving for the side. So both of those equations are just set up differently. They mean the same thing. Okay. In example 3, they do not give us a picture to go off of. We have to create the picture. So it says the two trains are leaving a station on different tracks. Okay, so I'm going to go ahead and I'm going to put a dot down here for like station. Okay, the tracks make an angle of 125 degrees with the station as the vertex. Okay, so 125 degrees is a little bit more than 90. I'm going to go ahead and draw like an obtuse angle that goes something like this, and we're going to say that this is 125 degrees. Okay, so we'll do that. The first train travels at an average speed of 100 kilometers per hour. So this is 100 kilometers per hour. And this one is going 65 kilometers per hour, so not quite as fast. Okay, but then they say how far apart are the trains after 2 hours? Okay, so basically if they're going like that, they want to know what the length is from here to here. We'll make that a straight line. It kind of looks curved. But they want to know what the basically the distance is from there to there, but then they say after 2 hours. Okay, so that's the tricky part. If this is 100 kilometers per hour after 2 hours, this shouldn't be 100 anymore. This should actually be 200. And this should actually be like 130, I think, is what the length would be. So as soon as 2 hours have elapsed, the first train should be 200 kilometers away from the station. As soon as the second 2 hours have elapsed over here, this train should be 130 kilometers from the station. Okay, so then we just have to figure out what x is. So x is referring to the side that we have. So I'm going to go ahead and use this one up here. Okay, it's just the way that the equation's set up. It makes it a little bit easier to solve. Okay, and then we have to decide where we're going to put all of our information. Okay, so x is the side that I'm solving for. I'm going to plop that in for a. Okay, so I'm going to call that x squared equals. Okay, now if this is a, then cosine of a has to be the angle that's opposite from a. So these two things are opposite each other. This one is the angle, this one is the side. Okay, so they give us, thankfully, the angle, I'm fuzzy now, sorry. They thankfully give us the angle that's opposite the side of x, or the side of a, and that's 125 degrees. So over here I'm going to have cosine of 125 degrees. Okay, and then I just have to plop in numbers for the other ones. So it does not matter which one we call B and C. So let's just refer to this one as B, this one as C. We'll do that. So this is going to be 130 squared plus 200 squared minus, and then we have in the equation 2 times B times C. 2 times 130 times 200. Okay, and that's what cosine of 125 is. Okay, so I'm going to plop this all into my calculator. If you need to do it in pieces, go ahead and do that. We'll see what we get. So, equals. If you type this all in one shot, it will be 130. Oh, let me turn it off. 130 squared, okay, plus 200 squared minus 2 times 130 times 200, and then cosine of 125. Okay, now my calculator, I have a dumb calculator, but it still says we're reading in degrees. Okay, so maybe that's one thing that you might want to check, is that your calculator is still reading in degrees, because 125 is in degrees. And we said that yesterday, that 1 degrees needs to be degrees. Okay, so enter, and I got a huge number, kind of fuzzy, 86,725.97 is what I got for my x squared. Okay, but then that's just what x squared is. I need to take the square root of that. So I'm going to do the square root of the answer. Then I don't have to retype anything all back in again, and it uses the exact answer. And x is going to be 294.5-ish, okay? Now think about what that means, okay? 294.5 will be the kilometers, since we're in kilometers, the distance that they are apart from each other after 2 hours, okay? So 294.5 kilometers, okay? All right, pretty short and sweet that example was, and then they give us this example down below here where they do have a picture drawn. But they've got a couple different triangles going on here. A 100-foot tall antenna tower is to be placed on the side of a hill. Okay, so 100-foot tall, they're placing it on the side of a hill, and what they're doing is they're strapping this down with cables. But since it's on the side of the hill, this side cable is not going to be the same length as this side cable. Okay, they're going to have to use different lengths. It is to be anchored by 2 cables from the top of the tower to a point 85 feet uphill and 95 feet downhill from the base. Okay, so they're saying this distance here is 85, this distance here is 95. And then they say that there's a 12-degree slope of the hill. Okay, so we're going to use that to kind of talk about some angles here. But they want to know how much cable is needed. Okay, so the cable is represented by this line here and this line here. So basically the length of my cable is going to be found by adding the lengths B and K together, right? If I add those 2 lengths, that'll give me the length of my total cable. So what I'm doing here is I just need to find out what B is. I need to find out what K is, okay? So just separate these guys out. Let's start with this triangle here. I'm going to take him and separate him out and write out what we have him looking like. Okay, so this is B. I know that the bottom side is 95, and I know that this side is 100, okay? So I want to be able to use the formula that I did up on example 3, but I don't know this angle. So if you can see example 3, I had the 2 sides opposite. I had the angle in between here, and then I had the side that I was solving for that was opposite the angle. But I don't know what this angle is. So let's see, they give me an angle of 12 degrees. Let's see if we can figure out the measurement of this angle right here based upon that 12 degrees, okay? So if I look at this 12-degree right triangle that's right here, okay, I can see that that little right triangle, this is a 90-degree angle, and this guy is 12. So let's talk about this little angle inside of that right triangle there, okay? So think about what can you use to solve or find out what that angle would be. Okay, I know that all 3 of these have to add up to be 180 degrees, right? So this 12 degree plus the 90 degree plus whatever this angle is has to add up to be 180 degrees, right? So I can add those 2 together. That would be like 112 or 100, blah, 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 blah. 102 plus my question mark would be 180 degrees. And then that would mean, if I subtract it from 180, that would mean that this has to be 78. So this angle right here is 78 degrees, okay? You could have done that by not setting it equal to 180, but saying that, okay, if this is 90 degrees, then 12 plus this guy has to be the other 90 degrees. So you could figure that out as well from that, okay? So then if I know that that's 78, okay, the one across from it, this is going back to geometry, the one across from it has to also be 78 degrees, right? Those 2 are called vertical angles. They're across from each other, right? Then this angle has to add up to this one to be 180. So this angle right here would then have to be 102. Okay, so now I know this angle is 102 degrees. Okay, he's on a straight line here with this 78, so that one has to be 102 degrees. Okay, so now I have all the information that I need. I'm just going to do this problem again, kind of like I did up above there. So b is the variable that I'm solving for. So b squared equals, I'm going to do cosine of 102 over here, and then just fill the rest of the stuff in. Okay, doesn't matter what b and c, or what technically your b and c are. So we'll just put the 95 first. 95 squared plus 100 squared minus 2 times 95 times 100, and then I have cosine of 102. Okay, so practice typing that in again. We'll figure out what b squared is. Okay, and let's see, you can see this a little bit better this time. 95 squared plus 100 squared minus 2 times 95 times 100 times cosine of 102. Okay, and we get another big, huge, long number, which is fine. 22975.32-ish. Okay, but that's not what b is exactly. I want to take the square root of that. Okay, so I'm going to do the square root of my answer, and b is 151.6, let's say. So 151.6. Okay, that's how long that cable is for b, that length there. Okay, now let's go ahead and write some units in there. What units will 151.6 be? That will be in feet. Okay, so I figured out that first side. Okay, now same thing for the other side. I need to figure out what the length of cable K is, and it's not going to be the same as length of cable B. We kind of talked about that already. But K, if I write him out, K is that length. Okay, I'm just redrawing this triangle here without all the junk in there. This guy is 100. And then we need to know what this angle is. We kind of talked about what he should be. He is opposite the 78 degrees, so he should be 78 as well. Okay, and then I can go ahead and use my law of cosines to find out what K is. All right, so K squared, we're going to go here. That means I have to take cosine of the opposite angle, which is 78. Okay, and then it doesn't matter which one I put first, so I could do 100 squared plus 85 squared, or 85 squared plus 100 squared, it doesn't matter. Let's just go ahead and do 100 first. 100 squared plus 85 squared minus 2 times 100 times 85, and that's cosine of 78. Type it all in, see what we get. Okay. 100 squared plus 85 squared minus 2 times 100 times 85 times cosine 78. Still in degrees. I hope I took that all in right. Let me go back. 2 times 100. Yep, okay. So K squared is 1369 with a 0 on the end, 0.5. Okay, something like that is what K is. Okay, to find out what K squared is, to find out just K, take the square root of that. So since it's already typed in my calculator, I'm going to do the square root of the answer. Then I can be lazy and not type again. So the cable here is 117.0 feet. 117.0 feet. Okay, let's see if we've answered the question. How much cable is needed is what they ask total. I'm going to make my screen really big. How much cable is needed? Cable is both of these we said added together. So length of B is 151.6. Length of K is 117.0. Add those together and we get 268.6 feet is how long of a cable we will need to strap it from here all the way to here. Okay, pretty easy, all right? But looking at this diagram to start with, it's kind of overwhelming, okay? Just think about what they're asking for, separate them out into two pieces if you need to, okay? And then the angle that they gave us, we can use to find any of the other angles that are there, okay? All right, that is what I have for you for homework, okay? You guys should have taken home the other day a sheet that looks like this, so law of sines, and then on the back side is law of cosines, okay? Or whichever one is the front side, it doesn't really matter. We have not done the law of cosine or law of sines yet. That's section 10.2, so that's in the next video. But what I want you to go ahead and do is the law of cosines here, and this has to do with there's 4 problems here. Has to do with the formulas that we've just gotten done talking about. Let me make this not so fuzzy. Okay, there's not really any instructions to this 1, 2, 3, 4. So it's like, okay, well, what do I do? The instructions for each one of these is to solve each triangle. Okay, so maybe you want to write that on here. Solve each triangle. And what that means you're doing is you're solving for everything that's not already there. So I would just go ahead and start by writing out capital A, capital B, capital C, lowercase a, lowercase b, lowercase c. some of those things that you already know what they are. Okay, so capital A is going to be 41 degrees. And let's see, then B, if I'm looking at capital B, we don't know. Capital C, we don't know. Capital or lowercase a would be the one that's opposite 41 degrees, okay, which we don't know either. But then you think which one of those is B and which one of those is C. B's got to be opposite B, so this guy is 3, and C's got to be opposite C, so this guy is 7. Okay, so use your law of cosines formulas to find the other 3 things. Same thing for 2 and 3 and 4. It might be a good idea to draw a picture of what this looks like for number 3. So maybe to get you started, I don't know, here's a triangle. This is maybe close to 71 degrees. Okay, so this would be C. Let's say this is A and this is B. Lowercase a is going to be 3, so that has to be here. Lowercase b is here. So that gets you kind of set up if you need that picture that you can draw and then solve for what the other pieces are. Okay. They do give you the formulas down here, so the 2 that you're going to use for this homework assignment, oh, come on, fuzzy, there we go. 2 that you're going to use for this homework assignment are these 2. Those are the law of cosines that we've talked about already. So use those to do these 4 problems. And then what I'm going to have you do is probably take a picture of this and send it to me, but I'll give you instructions for that, and I'll probably just have you wait and send that until after we finished section 10.2. So go ahead and do this part, but I'm not going to have you submit it yet until we do the back side of the sheet, and then I'll have you submit it all at once. Okay? All right, so that means don't wait till the last minute to do it all. Go ahead and do it now, but we'll submit it later. Okay? There you go.